In this lesson, we're going to focus on rotational symmetry. Rotational symmetry, the rotation is around a fixed point. A rotation does not change the shape or size of the figure. Therefore, the image and the preimages are congruent. Remember that word congruent. It means same size, same shape. Rotations can be described in degrees and direction. Direction is referred to in rotation as counterclockwise and clockwise. Counterclockwise is a left turn and clockwise is a right turn, and we'll look at some examples of those in just a second. The degrees can be found by finding two corresponding points, one on the image and one on the preimage, and then you draw a line through the origin as long as the origin is what you're rotating around. And then you look at the degrees of the 2 points connecting. In this example, we're looking at the transformation that would take figure A to figure B. So figure A to figure B. How are we going to get figure A to figure B? Okay, so we've said this is a rotation, so it's turning. So it's going to turn around the origin. So let's take a look. We would have a clockwise rotation of 90 degrees because this image is turning clockwise 90 degrees. Okay, so you can see this turn go at the turn to the right. It's falling down to the right, so that means it's clockwise. So looking at that animation, we can see that it is a clockwise rotation. Okay, think about how a clock moves. It moves to the right. Okay, so that one was a clockwise rotation, and let's look like if we connect the points. So we're going to select one point. I'm going to specifically select the tip because it's easy to see. Connect that to the origin because we're rotating around the origin. And then I'm going to connect the origin to the other tip. And then we can see where they got that 90-degree rotation because it is creating a 90-degree angle from the tip of this object to the tip of the image. Let's look at another example. On this one, we're going to look at which transformation takes figure A to figure B. So how does A get to B? Okay, which direction would you go to get from A to B? Okay, which one, A to B? Either would work. So let's look at the animation of how that happens and then talk about how we would find the degrees. So looking at that animation, it is moving counterclockwise by 180 degrees. So let's look at how we found the counterclockwise. This one, the author of the problem tells it's a counterclockwise rotation of 180 degrees, but I would say this one could have been a clockwise also. But let's just look at what the clockwise motion does. It takes us from here and around. So you're going from here and around, which if the clock were to go that direction, it would not be its natural swing. So that's why we would call it counterclockwise. How do we look and notice the 180 degrees about the origin? So that's where you connect 2 points, the same point. So I'm seeing the letter A and how it's written. So I'm going to take the tip here and connect it to the tip over here. So I am going to go through my origin. If I go through the origin, stop there. But then I'm going to connect it to the tip of the other object. It's continuing on straight. And a straight angle is a 180-degree angle. So that's where we got that 180 degrees. So we got to dig back deep and remember your angle measurements. Okay, we're only going to focus on 90 degrees, 180 degrees, and 270 degrees. So thinking about a clock, if you were to mark up that clock, okay, 1 turn on a clock is 90 degrees. 2 turns on a clock is 180 degrees. 3 turns would be 270 degrees. If you were to go full circle, that would be 360 degrees, which we're not going to do. So you can think about it turns in as a clock also in those degrees. Let's look at another example. Which transformation would take figure A to figure B. How are we going to get from A to B? Okay, so you have to really look at the tips and how they would swing. See if you can visualize it. Here is where I talked about using an plate or even a clear plastic lid. If you have a plastic plate and you want to hold it up to your computer screen, you can use a marker and trace figure A. And then you could actually spin it until you get it to land on figure B. Okay, so this is where that plastic plate that I suggested that you have comes into place. Like I said, it's not required. It's just a tool that can help you figure out how A gets to B and how this dot lands here. Okay, so that you can match up your dots, or if this dot is matched up here. So if you trace on that plastic plate, so hold it up the screen and trace it, and then put the center of the plate over the origin and turn it, you'll think, okay, am I making 1 turn, 2 turns, or 3 turns? Okay, so if we do that, we see that that one is spinning clockwise 270 degrees. So really focus in on this tip up here and notice it swings up and around. Swings up and around, and it's going around the origin from here to here. So this one is a clockwise of 270 degrees. And these problems are all multiple choice that's going to help you choose whether it's clockwise or counterclockwise. Okay, so then let's look at how we find the degrees. Okay, so we're going to connect the tip point to the origin because it is rotating around the origin. Let's see if I can get a little straighter here. So it goes to that point. Okay, and then I'm going to take from the origin to the tip of figure B. And I notice at first glance, I think that is a 90-degree angle. But I noticed that they said that it was a clockwise rotation. So that means we're going like the face of the clock, and we're going to look at this angle measurement from here all the way around. So it made 1, 2, 3 turns. That's how we got that 270 degrees. Okay, so make sure you focus in on the clockwise and the counterclockwise to understand which direction you are measuring your angle, whether you're measuring the inside or the outside. All right, please go ahead and work through all parts of today's Delta Math lesson, and we will talk about any problems you have questions on. Feel free to message me or reach out and we can chat.